Okay, one of the types of problems that we get led to by dealing with inequalities, linear inequalities, is we call linear programming. And these types of problems are popular in management science and some other applications. But ultimately what we're trying to find is a minimum or a maximum of some system of equations or inequalities. Okay, and generally what we're going to do is we're going to identify an objective function. Okay, this is what we want to minimize or maximize. Okay, and if we have such a problem, we call it a linear programming problem. And then the feasible points are just points that are part of the system. Okay, and these points are generally going to be the solutions to the inequalities that we're given. Okay, and we call those constraints. So this first part here is just some vocabulary. Okay, the solution always occurs at one of the vertex points or corner points along any boundary region. Okay, so what we're going to do is we're going to have some different constraints, which are going to be the inequalities we're going to write based on the information given. And when we figure out what the shaded area is, okay, any of the corners of the shaded area are going to be possible solutions. Okay, and so what we're going to do once we get those corners is we're going to plug them into the objective function, and then see which one is the biggest or the smallest, depending on what we're after here in terms of maximum or minimum. Okay, so that's kind of an overview of the process. Let's take a look at this problem. It says we're going to find the maximum, minimum values of the objective function f equals 3x plus 4y. So in this particular case, it really doesn't matter what the f stands for or what the x and y are, but ultimately this is our objective function, which may be given directly or it may be written in the context of the problem, depending on what problem we're given. We want to find the maximum and the minimum values of this objective function subject to the following constraints with this system of inequalities. Okay. Now, we're going to do, you can do this one of two ways. When you draw this, okay, you can draw it by hand, certainly. I would, for time's sake, I would probably use my calculator to find the intersection points that we're going to be after here in a minute. But with that said, just to get an idea of what the picture looks like and what we're trying to do, if I label these numbers 1, 2, 3, and 4, okay, and I graph all of them, I'm going to graph 3 and 4 first because they really are already graphed here. X equals 0, of course, is the y-axis, and y equals 0 is the x-axis. And notice that they're both greater than, which really just takes us into the first quadrant only. Okay, so greater than x equals 0, greater than y equals 0 is going to constrain us to the first quadrant. So none of these other quadrants are going to be part of our region, we know at this point. And that's a lot of times the case with these types of problems because it doesn't make sense to have negative values for x and y. Okay, not always, but most of the time, okay, the x and y's are going to be positive. So first quadrant for sure. And then we're also going to be bounded by 3x plus 2y is less than or equal to 12. So I'm going to make an xy chart for that, find the intercepts. So if I put a 0 in for x, I'm going to be left with 2y equals 12, which is 6, if I solve it. And 0 in for y is going to leave me 3x equals 12, which gives me 4. So I'm going to do 1, 2, 3, 4, 5, 6, 0, 6, and then 1, 2, 3, 4. And this is certainly going to be better done on graph paper, of course. You'll notice that I did not extend it into the other quadrants at this point because the other quadrants aren't important at this point. We know that first quadrant only. We also, if we do a test here, we would have 0, 0 if we use the origin. 0 is less than or equal to 12, so we would shade the underside of the line. Okay, so at this point, the triangle is the part that's shaded if I were to shade now. But I'm not going to shade yet because there's one more constraint. So right now it's the triangle, so keep that in mind. And if we make an xy chart for 2x plus 5y equals 19, and we put a 0 in for x, we get 19 fifths. Okay, of course 19 fifths would be 3 and 4 fifths. Okay, so 19 fifths or 3 and 4 fifths. And if we put a 0 in for y, we're going to get 19 halves, which of course is 9 and a half. So if we're going to graph those, so we have 0, 3 and 4 fifths, and we have 9, 5, 6, 7, 8, 9, 10, so 9 and a half, and we would have that as our other constraint. And 0, 0 would also make this true, so we want the underside of that line. So if we put all of that together, then our feasible region is really that right there, isn't it? Okay. Under both lines at the same time and in the first quadrant. Okay. So that right there would be our feasible region. And now, once we have the feasible region, now we'll go back to our objective function. And we're going to plug in the corners of the feasible region into that to decide which one is the maximum or the minimum. Okay, so we can see that one of the corners is 0, 0. Okay, so again, it's going to make some kind of polygon here, and the corners of it are going to be the possible answers here for maximums or minimums. So if we put a 0 in there, we're going to get 0, okay, which is pretty likely to be our minimum at this point, wouldn't you say? Okay. If we put in this point right here, which is 0 for x and 3 4/5 for y, okay, the answer is, let's find out. We can do it by hand, of course, but just for time's sake, we'll use the calculator. And remember, when we type in a mixed number here, we can go 3 plus 4/5 in parentheses. If we use our parentheses correctly. And then, of course, we can do math frac to get it back to a fraction when we're done. Or we can just recognize that it's 15 1/5. So that would be our answer for 0, 3 4/5, which is this one. Our next constraint would be 4, 0. Okay, our next feasible point. So if we put in 4, 0, we're going to get 3 times 4, and 4 times 0, and that's going to give me 12. So far 12 is pretty much out. It's not the maximum or the minimum because we have one smaller and one bigger so far. And then the final point is going to be the intersection between those two lines. Okay. So we have methods for finding the intersection between two lines. We can use elimination or substitution. We could use matrices, okay, or we could use graphing. So it's really completely up to you, and I'll leave it up to you to decide which way you want to do it. If you want to solve both of these for y, put them in the calculator and use the intersection command, you may do that. Okay? Or if you want to use elimination, fine. If you want to make matrices out of these and do them, that's fine too. It's completely up to you on which way you solve this system right here and figure out that intersection point. Ashley?
What do you think when f of x equals 3x plus 4y?
Given.
Okay.
So that was given to us in the beginning. So just for practice sake, I'm going to do it the matrix way to solve this system. So I'm going to do matrix edit. I already got a 2 by 2. I'm going to do 3 and 2 and 2 and 5. And then if I do matrix B, make that 12 and 19. And then I do matrix A inverse. Here's my inverse. Multiply that by matrix B. And we get our two answers. In this case, turns out to be a nice answer, 2 and 3. Okay. So, and again, if you do this with a graph paper, you could possibly eyeball that and see that it's 2, 3 here, but I would suggest still solving it with algebra one way or another. So that means if I put a 2 in and a 3 in, that's another possible solution. And if we did that, we'd get 6 plus 12. 6 plus 12 is 18, and therefore our minimum would be 0, and our maximum would be 18. Okay? And again, it said find the maximum and minimum values. Okay? So find the maximum and minimum values. The answers are the values. So 0 would be the minimum value, 18 would be the maximum value. And they also might ask us and tell which x and y gives you that. Then you would list that 0 comes from 0, 0. 18 comes from the point 2, 3. Fair enough? Questions on any part of that process so far?